Okay, hi. Thanks for having me. My name is Kim Albrecht. I work at the Center for Complex Network Research in Boston. We're doing a lot of network research and data science. I'm not so much of in medical, but I can show you some visualization work. So my colleagues are mainly physicists, and I'm a designer who's working in the field of visualization. And what I want to show you tonight are like three parts. So I'm first going to start with some projects I do to give you an introduction. And then I'm going to show you some basic guidelines to visualization and also give you some tools that you can work with on different levels. So I became interested in visualization during my bachelor's in graphic design. And this was one of my first pieces I did. It's about billionaires, so every endpoint here of this very blurry picture is one billionaire on planet Earth. And they're categorized into the countries they come from and the areas where they made their money in. So this is United States banking. These are the states. And yeah, it's like 1,500 people and where they're from and where they make their money in. And then I also did something like this. It's about meteoroids and where they fall down on planet Earth. And from that time on, all those charts are static and like printable pieces. And I became more and more interested in interactive visualizations because you can show much more data. And for my master thesis, which I did in Potsdam with Mark, I did a piece called culturography. And what I got interested in was how in culture ideas are transformed. So this is Fritz Lang's Metropolis from 1927. And that's Star Wars, which came out 50 years later. And it's said that George Lucas actually copied the robot from the one movie to the other. And at IMDb, they're writing all these things down. So whenever they find a similar quote or they find like the same scene or the same settings, they're writing these things down. But they have it like in big lists, and nobody goes through them, and nobody knows this kind of things. So I took this kind of information and visualized it and put it into graphic form. So what we see here is a timeline from 1940 to 2010, and we see in the center the movie The Matrix. And we can see all the movies who inspired The Matrix and the movies which got inspired by The Matrix. And this is interactive. You can visit it on the web. And yeah, now we can just look at which these movies are. And also like the movies who inspired The Matrix. And by clicking on these dots, you can get you can walk through this kind of visualization and look at all kinds of movies and explore how these inspirations work.
Short question.
Mm-hmm.
Color have a certain meaning?
Yes. So I can show you this in the next. So it's always it's a line, and it always starts from blue. So that's where the idea comes from, and it always goes to red. So that's always like the way it works. Like, and
question.
Yeah.
What is on the x-axis? You explain the y-axis would be time.
Yeah, I can explain that. So the x-axis is an index. So for each movie, I put them one further, and I sorted them by time. So like that, you get this nice curve where you can see that The Matrix actually get its main inspirations in like the 90s or 80s, and then there are only very few movies who inspired The Matrix before that. So that's the sorting on that axis. And yeah, we've got this one, which is another visualization. So in the first one, you only saw one movie, and now we look at 100 years and 3,000 movies at once. And here the sorting is, again, time, and then this axis shows you how famous this movie was. So this is The Wizard of Oz. And just before that, we had Star Wars, which have the most references. And we can click on those and then see like this kind of patterns that actually The Wizard of Oz, it took 30 years until anybody referenced this movie. which is kind of interesting because it's a second most referenced movie, but it didn't really came up in this scene. And other movies like Psycho got referenced right away. So we can see these patterns in this kind of huge data set.
I have another question, please.
Yes, please.
Why did you, is there any particular reason that you put the time axis on the vertical axis and on the horizontal axis, as typically preferred in the reporting, let's say, visualization community?
I don't know if it's really preferred in the visualization community. This kind of idea to put the time on the horizontal axis is from biology. So it comes from like a biological tree of life. So that's where I got the inspiration from. Yeah,
okay.
That's like. So, and one question I asked myself throughout all this projects was, okay, who am I doing this for, and what's the real value? And it's one of these questions which sound like simple, but it's actually unclear and not so easy to answer often. So I work with quite a few scientists in this project, but it was always a very difficult to answer question. And since this year, since January, I'm in Boston. And I'm working at a lab called the Barabasi Lab, or Center for Complex Network Research, with like 30 physicists, and they have a lot of questions, and they have huge data sets. So this is kind of interesting for me because it changes the way I work, and I'm the only designer in the lab, so I'm like very different from all the other people who are working with me, which is kind of interesting. And what I'm trying to establish there is an ecology of graphics. So what I mean by that is that I'm trying to build explorative visualizations which help them to understand the subject matter, but also to understand each other. So often we have interdisciplinary projects, and often they don't really, it's difficult for them to talk to each other. I've got one project with political scientists and physicists, and they talk completely different languages, even if they use the same words. And these visualizations can be used as like a reference, as a guideline for these projects. And at one point, all these tools are interactive and based on web standards. So at one point, I can put these tools out there and they can be used online. And now I can show you one or two examples of this work. So this is a project we're working on, and each circle represents one tennis player. And what we were interested in is how is popularity and performance correlated to each other. So we know people like Paris Hilton or the Kardashians who are very famous, but nobody really knows why or what they're really capable of. So we were interested, how is that in sports? Are people famous because they're good, or are they famous for other reasons, and when? What are these reasons? So we can hover these points, and maybe you can read some names. And so each circle is like one tennis player. We've got like Rafael Nadal, Novak Djokovic. So this is like the ranking. These guys are like the top in tennis. And then on this axis we have Wikipedia page views. So we know, or we scraped all the information from Wikipedia and know how many people visit their pages. And then we've got outliers like this one here, Marko Djokovic, who has much more page views than all his colleagues here, which are down here. And he's actually the little brother of Novak. So that might be a reason, but we can see more in here. So we've got different ways of sorting this. So we can, for example, change the axis and look like, okay, how long do they actually play, and how many page views do they get? Or we can also sort them by multiples. So instead of putting them on a scatter plot, we now sort them like by rows, and we can see how the ranking is in comparison to the page views. And you might wonder, okay, why aren't this like normal circles? What is this? Why are they have these strange shapes? So this is a rotated version of when we click here, this is extending. So what we can see here is like every tournament they ever played in their life. And the ranking they had at that point, and the length of the line shows how many rounds they played. So we can see that here he only got into the final once, and we can see how much valuable, how valuable the tournament is, and how difficult his most difficult opponent was in the game. And we can see people like Tommy Haas, who got injured 3 times in his career and always dropped completely and then tried to build up again. And my colleagues, they are like physicists, and physicists like to predict things. And so this is a popularity over the last 5 years from the Wikipedia pages. And my colleague built a model to predict this kind of Wikipedia pages from the performance data that we have. And what we see here is a comparison. So the smaller these areas are, like, for example, this person here, this is very good. This means that the model predicts very well the Wikipedia pages. And the bigger these areas are, the worse the predictions are. And we can click on them and then get the Wikipedia article and read through and try to understand what's the problem or what we need to change in the model. So this is how, like, my colleagues are working with these kinds of tools. And yeah, it's interesting. And we can, again, put this in all kinds of different scales and play around with this. Yeah. Now from tennis players to the universe. As I said, we're quite we've got quite a big range of topics. So what we have here, every point is a galaxy, and it's known that the universe is not evenly distributed, but has this web-like structure. And we are actually trying to model this kind of web-like structure. And this visualization shows different models that we built in the lab. And my colleague, he's first only looked for the first 2 years, he only looked at this in a statistical way. And now I came and made this visualization for him, and it was the first time he really saw the data and not just had like one statistical point. And this is kind of interesting for him, and it's very beautiful, I think. So, and yeah, what they are using then is like this kind of clusterings where we only look at certain parts, and then he's comparing the different models. And yeah, we're trying to publish this soon. So from here, let's get this to the basics. So we're here tonight, so you can also learn a bit about this kind of work and get a bit deeper. So we're just going to start with what information visualization actually is. And there are different ways to think about this question. One way is in a chart like this, where we've got information, design, and communication, and data visualization is somehow at the center of this kind of graphic. So this Venn diagram, this beautiful Venn diagram, talks about the different components that are necessary to do visualizations. But we can also think about visualization as a process, so as a process within computer science, statistics, and then this visual design, and where we like have this kind of guidelines through the process of building these charts. But what I think is really at the center of visualization is amplifying cognition. And what I mean by that, approximately half of the brain is devoted to vision. I'm not sure if that's right. That's like a scientist who's saying that. But for me, it's a big thing. I mean, half of our brain, it's like a lot. And I think what we can say, there's a connection between what we see and what we think. So this becomes very clear in the metaphors we're using. So if we understand something, we call it seeing. I'm seeing the truth. I see your point. And this is a word we use. And it's the same as making ideas clear. I mean, this clear, it's like a visual thing that we're using for thinking or to focus on something. It's a very visual kind of language that we're using. And you can also think of this as like if we think about calculation, so if you should calculate 34 by 42 in your head, it will take you some time. On average, it takes 50 seconds. If I visualize it like this, it takes you about 10 seconds if I give you pen and paper. So this is a form of visualization for me. So we've got this big difference. And Japan is one step ahead of us in this respect. So they've got a technique which is even more visual than what I just shown you before. So we've got this 3 and we've got the 4. So we're putting this into lines. And then we overlap it with the 42. And now all we have to do actually is count the crossings. So how many crossings do we have? And we can put this in a chart like this. So you count all the crossings in these 3 areas that we have. And if you combine this, you've got the result. So this is actually externalizing memory and externalizing your thinking process. So, and I think that's the power of visualization. That's what visualization can do and help you and make your process much more easy. So, but there's a bad or difficult side in this, which is getting from the data to the form. And for the beginning, I would like to start with the most simplest data set we can imagine. 2 numbers, and we're going to hand out some papers for you. And I would like you to find as many possibilities as you can to visualize these 2 numbers in the next 4 minutes, maybe. You can do whatever you like. You're absolutely free. Okay, are we done with this? Nice. So the point of this is that even for like the tiniest data set we could imagine 2 numbers, we can actually find like a huge variety of different visual techniques to apply. And there's no perfect solution. There's not the one visualization. And the more dimensions you have and the richer your data set is, the more difficult this becomes. And visualization is really more just like a language where you can use a lot of different expressions to say the same, or to say something else, or to let it sound differently. What's nice about this project, we are not the first ones who are doing this. So there are many people, and there's a collection of 45 of this of different visualizations, how you could visualize these 2 numbers. And we're going to hang up like all of the versions you made, and we can just go through this, and you can see like all the different varieties these people came up with. So we've got bars, we've got line graph, we've got percentages, we've got spliced bars, proportions, intervals, pie charts, donut charts, circle charts, semicircle charts, you name it. Like, and then the lower we get, the crazier it becomes. Gray tones, color. So yes, there's a huge number of different ways to. I like this pulse frequency. Anybody drawn that? Okay. So. Yeah, I think. So, but there are a few rules. So, not everything works as good as anything else. So, first we need to understand this language a bit better. And there are 3 components to this language, as I would say. And the first one is data types. So, we've got different kinds of data, and this is just one way to categorize like what kind of data we have. So, we've got categorical, where you can say there's an apple and there's an orange, but we can't say how they how they are one compared to the other. Or we can say the one apple is bigger than the other one, then they are like ordinal. Or we can say quantitative. The one apple weighs that much more than the other. Or we've got relational data, which are like hierarchical data, where they're connected to each other, or network data. And we've got spatial data, so geolocations. And we've got temporal data, so time involving. And all those different data types, we can plot them on 3 main forms, and that are points, lines, and areas. And we can work with those. But these different form types, they've got form variables. So we've got position, size, value, texture, color, orientation, shape, and also now on web we've got animation. And this is based on Jacques Bertin, so he was really the one who brought this into life. And yeah, we've got this 3 different kind of things we need to think about when we try to map data onto form. So the next time you see a chart like this, for example, in the New York Times, you can not only think about Obama and Romney and how they compared in the election, but you can think about the categorical data, like the 2 candidates. And you can think about the ordinal data, the states. The states are ordinal in this case and not categorical, because they're ordered by how many votes the states have. So Florida first, Ohio, North Carolina, and the lower we get, the smaller the state is. And then we've got also this kind of tree structure. So we've got this relational data in here. And then we've got this, the color, which stands for the candidates, for the different. And then we've got the Y position, which is for the state. And the X position, which is for this tree structure. And we've got the line thickness, which talks about the seats in each state, so each candidate can win. So this kind of data is much more complex than the 2 numbers we had, but still we can like categorize this and order it into these different sections. And this is what visualization research is really all about, or this is a part. And now I would like to tell you something about like this, what works well and what doesn't work well. So we've got Tufte, and he talks about graphical excellence, and he has 3 main points. So one thing you need for good data visualizations is interesting data, so complex ideas and multivariate data. And you need a good data ink ratio. I'm going to show you in the next slide what this means. And you need accurate communication. I'm going to talk about this also a bit later. So these are 2 charts, and they have exactly the same data set underlying, but the one is like added some icons, and we've got this pyramids. It's a bit hard to see, and this one is kept very clean, and like everything is taken out that's really not necessary. And for Tufte, this kind of the second chart works much better because it's reduced and it really focuses on the data rather than on graphic elements. And that's what the data ink ratio is about. So, and these are just some things that he says are necessary. So, and if we go a bit deeper into this, we can think about color. And color is great. I mean, like color is this like, if we try to find the apples in this image, it's very difficult. And if we add some color, they just pop out and becomes very easy to see. But color is also evil. If we look at this image, A and B, which one is lighter, which one is darker? Who says A is lighter? Oh, it's the same. Everybody knows this one. Yes, they are the same. So color very much works in a context. Color is not working on its own, but it's working like where color is and how we see color. And we can say the same about data visualizations. This is from Site Online a few years back. And it's very hard to see here, but we've got this area highlighted and then an area up there. And it's very hard to say which one is lighter or darker in this case. And only if we really look at this, we can still see that this part is actually darker than the other one. So this makes it difficult, but there's no, like in a language, it's not, we don't have this perfect visualization that would solve this. But there are some tricks or some hints what color can do. And I think color is good for two things. One, for emphasizing. So if we try to search all the 7s, it's much more easier if we highlight them. Or for grouping, it just pops out. So here's some tips. Get it right in black and white. Use colors mostly for categories, but not more than 5. And if used for quantities, try to use variations in brightness and not in color. So we've got very different color schemes, are very, very varying. So it can become very difficult. Some more about visual variables. So I would like to know how much bigger is the big circle than the small one. Who says double? Who says 3 times bigger than the small one?
What is bigger in your
how often can you fit this circle into this circle? So at 5, who's 5? 4. So we've got some 5s. 4? Who's 4? Okay. Then we've got 6. Who says 6? Who says 7? Who says 8? Who says 9? Who says 10? Okay. So 10 or more? Yeah, more than 10? Okay. So we've got a huge variety. Everybody said something else, and it was very, not a clear result. Let's see about bars. Who says this bar is double? Now you're laughing. Who says it's triple? 4 times as big? 5 times as big? 6 times as big? 7 times as big? Okay. 8 times? 9 times? Okay. 10 or more? Okay. So we had a much, the variety in your answers were much smaller. Here you were focusing on a better point. And both of them have the same number of, fit the same. So yes, we've got 7 times. So, and you were in comparing this kind of length, which was much easier for you than comparing the circle. So that's something we can say, and it's the same about this pie charts. Pie charts are evil. So it's very hard to say. It's very difficult to say which of the areas are how much bigger. If you look at the red, it's very difficult to say. And if we plot this in bars, it's a very clear result. I mean, who would argue now here that the red is not the smallest one, but in A we could argue about this. So there are some clear distinctions, what works better and what is not working so good. And the same with color. Color is super difficult. The bars are very easy to compare, and the circles are kind of difficult, and color is it's a very difficult field for this kind of comparisons. And there are a lot of studies who are looking at this, and we know that the position is the most important at any visualization, and length also works good. Angles are then getting more difficult, and then it becomes much more complex. So, and this is a kind of a good chart if you just want to have some kind of knowledge about how it works. So don't use color for comparing things, because it's just very difficult for us to see. What I would like to show you now are 3 different tools that you can use and you can work with. And the one is called RAW, the other Polestar. And then we've got 3JS, which I'm working with quite a lot. And I'm just going to jump in. So let's start with RAW. So it's actually very much what we did, or what we were plotting. So here we've got our data, and you can load any kind of data set in. You can just drag and drop it. And so now we have a data set about music and how music changed over time, or not music, about about media usage. And here we have like a lot of different charts. Some of them are really bad, and some of them don't really fit into what I just told you, but some of them are quite good. And the nice thing about this tool, it's super simple. So you just choose a data set, and then you've got your the things you can do here. So and you just drag and drop it. So we can say, okay, put the year, and then and we see something, but it's not that insightful. So we know all the media that this data set has. And now if we put the size and the market share, we get something like this. And we can see like how market share developed over the last 30 years in media usage. So we can see like how the LP actually died out, and then how the cassette came in, and then how the CD came. And now the download single is like, download single and download album are separated, which is a bit like, it's always tricky to set this kind of categories. But yeah, these are the kinds of things you can do, and we can also choose another kind of visualization technique, and then do the same thing. So we can just drag something here, and let's drag this here, and then color it by media. And we've got something like this. So we can build a lot of different visualizations very, very quickly. Some of them don't make sense, so I can drag some things on stuff. So now, I'm not sure if it's going to work either. Let's put the market share on the size. So now they're getting smaller. So we can do a lot of things. But the nice thing about this is you can iterate extremely fast. And then once you've got something that you're happy with, you can just download it in like vector files, or as an image, and you can use it. But this is more, this is not really to explore a data set. This is more playful. And then there's this tool. This works kind of well. So what we're looking at, we've got data about movies, and you can also upload your own data set here. And I'm interested in movies and IMDb rating, so I just drag the IMDb rating here, and then we also have Rotten Tomato ratings. So we can compare those two, and we can see like immediately, okay, which movies are rated very badly on Rotten Tomatoes and very good on IMDb. And we can hover this and see which movies are like this outliers that are very famous in one community but not well accepted in the other. And then we can go on and, for example, say, okay, now I want to know how this is for genres, and we just drag genres here. And we've got this small multiples, it's called. So it's a very powerful way of comparing different visualization techniques. And then we can see how the different genres. So documentary, for example, is rated very good, even if they're very little. And then there are a few that are not rated very well. But this is a tool, and you can download this as an image. So it becomes very, very quick and easy to build this kind of things. And we can also drag something else on like an axis and see what happens. Some variables don't work, so I might have broken the system. Okay, let's try something else. We can say number of votes here, yeah. And then we can see, so we can create this kind of matrices very quickly. Or then if we say, this is not really what we're looking for, we could say, okay, we want to have the gross on the size. So how much money did they make? And how well are they rated? So we can compare all kinds of things very quickly. And this is like all of both tools that I've just shown you are drag and drop, which is nice. They're easy to use, and you can build something very quickly. But sometimes you have to go beyond this stage. And this is where I'm done in a second, and I take a lot of questions. And I'm going to show you just one more thing. This is something done in D3. Let me zoom out a bit. So this is a charting library I'm using for most of my visualizations, and it allows you to create interactive visualizations. So you need to code this kind of things, but you can go through this. So this is a data set of of food, and you can choose all kinds of things and then see which one has like the most calories or the most calcium in this case. And you get this list and see what it is. And it's based on a huge data set, so we've got a lot of different different dimensions that you look at here, and a lot of different foods, and each dimension is plotted on one line. And yeah, you can go through this and then say, but I'm only interested in with a lot of water, and I want to know where they come from, which group they are from. So this is the same example, and just wanted to show you. This is the underlying code, so it's all based on JavaScript, and it's not too hard to learn this, but it takes some time. But it's very powerful. You can. So yeah, this is the data set, and then you've got this kind of code. I mean, like, this is what creates this kind of like visualizations that you can interact with and like see how the different dimensions correlate with one another and work together. Yes, that's it. Thank you very much.